Hello. Hello. Good afternoon, everyone. Now we are going to start the class. We are going to explain seventh unit. In this seventh unit, we are going to discuss arrays. So we are going to cover what about the introduction of arrays, and we are going to see one-dimensional arrays and multi-dimensional arrays, and what are the alternative array declarations, syntaxes that we can use, and assigning array references and the length members of an array. And finally, we are going to see for each style for loop which can be used with the arrays. So all these are the concepts that we are going to discuss in these arrays. Now here you can see, first of all, we need to define what is an array. What is the purpose of using arrays? Right. Generally, if you want to store any value, if you want to use any value in your programming, so how we are going to write that value, how we are going to take that value. Now here we are going to write int a. Now if that value I want to declare here itself, here I can write its value, or otherwise I can declare like this also, int b, right? So here a is one variable and b is another variable. Here a holds 10 and here b value can be taken from the keyboard, right? So if you take any real value, or if you take any character, or if you take any integer value, if we consider one variable, that variable can store only one value. So here an integer variable, this stores one integer value. This is also an integer variable, this stores another integer value. Suppose for example, if you are writing float z, this is a real variable which stores one real value, right? So like this, if I declare one variable means that can hold only one value. So, but sometimes if I want to store similar type of multiple values, similar type of data, that is all are integers, I have multiple integer values are there. If I want to store those multiple integer values, suppose for example, so I measured the temperature for 24 hours, right? For every hour I measured the temperature. But generally it is present as a real value. The temperature can be represented as a real value, right? Now, at the first hour, I have some temperature value. At the second hour, at the third hour, like that, I have 24 values. Now, if I want to store the temperature values for 24 hours, if I follow this procedure, I need 24 variables. Each variable can hold one temperature value, right? So, for effectively representing these 24 values or similar type of data, so we can use arrays. Using a single variable, we can represent all these values. Using a single variable, I can represent all those values. That single variable is nothing but an array. That single variable is nothing but an array. So here you can see array is used to represent to store multiple values in a single variable. So array is used to store multiple values in a single variable instead of declaring separate variables for each value. In the same example, if I want to declare separate variables, it needs 24 variables. But here, all those 24 values can be stored under a single variable if I am using an array. Now, how to define an array? An array is a group of continuous or related data items that share a common name. So, it can also be defined as an array is a collection of homogeneous data items that are shared in continuous locations. So how to define an array? An array is a collection of homogeneous data items, that are stored in contiguous memory locations. So this is another definition for array, right? An array is a group of contiguous or related data items that share a common name, or an array is a collection of homogeneous data items that are stored in contiguous memory locations. Now, a particular value is indicated. Suppose, for example, here I am saying that my array consists of 24 values. So on 24 values. Here I have given the name of this array as temp. So since it represents all temperature values, I am naming this variable as temp. This variable stores 24 values, right? Let us say. Now, here you can see an array is a collection of homogeneous data items. So all these are the real values. Here one real value is stored, here another real value, here another real value, here another real value. Let us say 24 real values are stored. Now, how to identify this value and how to get this value and how to get this value? So how to access each and every value, how to represent each and every value. A particular value is indicated by writing a number called index number or subscript in square bracket after the array name. Now, that is the index values for this array are, this element is represented with an index 0, this element is represented with an index 1, this element is represented with an index 2, and so on. Since 24 are there, 23, this becomes 23. Now, how the first element is represented? After array name, we are going to write a subscript value or an index value within the bracket, square bracket, after the array name. This is the array name. Now, if I want to access the first element, its subscript is nothing but 0. That 0 can be placed. If I want to access next element, I can write its subscript as 1. If I want to access last element, I can write its subscript as 23. Right? So like that, I can access the elements of array. Right? Next. So here we may have the one-dimensional arrays or we may have the multi-dimensional arrays. Now here let us say one-dimensional array. Now here, what is one-dimensional array? One-dimensional array is a list of homogeneous items that can be given one variable name using only one subscript. Okay, so one variable is given only one subscript value. Then it is to be called as one-dimensional array. It is a list of homogeneous items. Right. Now, how to create an array in Java? So here, creation of an array contains two sections. One is the declaration of array and another one is creating memory allocation or memory location to the array. Now here you can see the syntax for creating an array. Type array name which is proceeded with the subscript, which is represented with a one single subscript since it is one-dimensional array. So this portion is to be called as declaration. Next, whatever the array name we have written here, that array name is equal to new type now of size. This is to be called as allocation of memory. That is how much size we given, that number of memory locations can be allocated to this particular array. Right. This declaration and allocation can be combined in a single line like this. Type array name, new type size. Like that I can write. Right. Now here you can see the example. So here type represents the data type. Which data type that you want to store? Here I want to store integers. So here we have written integer and my array name is number. Since this is one-dimensional array, I am representing only one subscript. This entirely is to be called as declaration. This entirely is to be called as declaration. Now here memory allocation means whatever the array name here we are taking, that array name is equal to new. What is the type that we are using? Integer. Now, how many elements that I want to store? Size of that array. How many elements that I want to store? I can store 5 elements. Right. So, the required space for storing the 5 integer values can be allocated to this particular array. So, this is declaration. This is allocation of memory. Both these can be combined in a single line. How to write in a single line? Int number is equal to new int of 5 letters, say. Right. Like this, I can write in a single line. Right. So this is about the declaration of arrays. Now, how to initialize the arrays? The arrays can be initialized automatically when they are declared. Right. Now, at the time of declaration, how these can be initialized? Here you can see type, array name, list of values. Right. Now, here if I want to take the type as integer, int, here my array name is number, subscript is equal to, these are the list of values that I can take. In this case, since I given 4 values, the size of this array is 4 and the required space for storing these 4 elements can be allocated in the memory. Right. So, in Java, all arrays store the allocated size in a variable named length. So here, whatever it may be the size of the array, its size can be represented by using a variable named length, predefined variable. This is a predefined variable. Now, we can access the length of the array by using this syntax, array name dot length. That is, if I want to print the length of the above array, so how I can access? Number, array name is number dot length. If we write this statement in print, right, print number dot length, then what it outputs? It outputs 4. That is, since it contains 4 elements, it outputs the value as 4. Right. So this is how to initialize the variables. Sometimes we can initialize the array by using for loop, using the keyboard. Right. The array elements. So here we will take looping variable I starts from 0. If I want to store n elements, I iterates up to n value, or I iterates up to n, and I becomes plus plus. Every time one value can be readed. Initially, A of 0 is readed, next A of 1, next A of 2, like that I can read array elements using keyboard. So with the help of for loop, right? So here you can see an example representation of writing arrays. So how an array can be written, right? So here you can see the example of writing arrays. Now here we have written a class sample. Now here this is my main method. Now here I declare the array of size int. Here you can observe the difference. I can write the subscript either here or here. Anyway, I can write it. Right. So how you written? No problem there. So the same statement, how I can write? Int ARR is equal to new int of 5. Like this also I can write. No problem there. So the subscript can be represented either here or here. Right. Now, here I initialize the values. ARR of 0 is equal to 10. ARR of 1 is equal to 20. ARR of 2 is equal to 30. 3 is equal to 40. And 4 is equal to 50. Now, I want to print all these elements. Now, for printing all these elements, now I am going to take for loop. For I is equal to 0, I less than ARR dot length, I plus plus. Here, what is ARR dot length? The length of this array. Since it contains 5 elements, the array length becomes 5. So, I less than 5, I plus plus. Element value indexes can be printed here. Right. Now, here you can see, first I takes 0. So, and here it is less than 5, condition correct. So, first element is printed. What is the first element? 10. 0th element. At index, which is the element present, that element can be printed. At the index 0, 10 is present, so 10 will be printed. Next, I becomes incremented, it becomes 1. Again, it is less than 5. Now, condition correct. So, second element which is present at ARR of 1, that is printed. Next I becomes 2, third element will be printed. Next I becomes 3, fourth element will be printed. I becomes 4, fifth element will be printed. I becomes 5. In this case 5 less than 5, condition becomes false. Now all the elements which are present in this array are printed. Right. Now the same program, whatever the program here we have written, the same program can be written like this as well. So here you can see class sample main method. Now here I declared the array like this. Here I declared the array like this. Now here we printed the values. So like how we are taking each element one by one. So like this also we can take, or they can be represented in a single line. All the elements can be declared in a single line. Like this also we can take the array elements. Right. Now, next one. Here we are going to see one more example for array. Now here you can see whatever the here, this is sum is equal to 0. Here NO is my array name, which can hold 10 values. Now, out of those 10 values, I want to place only 5 values. So that's why here for number of I want to read the elements from my argument register. That is, here we are taking command line arguments. From that command line argument register, I want to take the values and I want to find the sum of those values. Here I find the sum of those values. Right. So here you can better understand if you see the execution of this program. Right. Now here I am going to show the execution of this program in my notepad. So here you can see this is my notepad. So which contains the same program what we explained till now. Now I am going to save my program. Save my program in desktop with the name, whatever the class name we given, with the extension Java. Right. Now here I save the file. Now I want to execute the program. Now here how I can execute the program, here you can see. So Java C, what is my file name? ARR1.java. Now here it is compiling that file. Now it is compiled. Now here I want to run the program. Now how I can run the program? Now here this is Java is the interpreter for running the program, and ARR1. Here I want to use command line arguments. Now here I want to enter the arguments. I want to enter the arguments, 5 arguments. Since I want to read 5 values, here I represented 5 values. I want to add 5 arguments. Now here I added the arguments 1, 2, 3, 4, 6. What becomes the sum of these 5 elements? 6 plus 4, 10, 3, 13 to 15 plus 1, 16. It should become 16. See whether we are getting 16 or not. So here you can see total is equal to 16. Right. Now here you can see this is the sum value. Whatever the sum value we are getting here, that sum value here we are getting. Right. So this is about your one-dimensional array. Right. Next you can see two-dimensional array. Right. Now here you can see a two-dimensional array is a collection of homogeneous data items that share a common name using two subscripts. Here, suppose for example, I want to represent in a two-dimensional array, temperature in a two-dimensional array, right? Now, how I can represent in two dimensions? In like this, I can represent. Like this, I can represent. Okay, suppose for example, this array represents the temperature values for 5 days. Day 1, day 2, day 3, day 4, day 5. For 5 days, I want to note down the temperature. For morning as well as evening. For all the 5 days, for morning and evening, I want to note down those values. Right. So here I am going to enter those values. Suppose for example, it is 98.0. It is 99.0, 97, 96.5. Like that, the values are noted. So here it contains 5 rows and 2 columns. Right. So here I can represent it as a table. Right. So why I am writing all these things is two-dimensional array is nothing but it is representing a table structure. So here whatever the lines we are writing horizontally, those are to be called as rows. Whatever the lines we are writing vertically, those are to be called as columns. Right. So totally 3 rows are there and 4 columns are there. So it can store 12 elements. It can store 12 elements. Now, how the first element is represented? Suppose the array name is X. The first element is represented with 2 subscripts. One is the row subscript and other is the column subscript. It is present in 0th row, 0th column. Right. It is present in 0th row, first column. 0th row, second column. 0th row, third column. This is present in first row, 0th column. First row, first column. First row, second column. First row, third column. Right. Like that, the values which are present in a two-dimensional array can be represented. So every element can be accessed by using 2 subscripts. Every element can be accessed by using 2 subscripts in case of a two-dimensional array. Now, how to declare these two-dimensional arrays and how to initialize the values, that we can see. Right. Now, here you can see the declaration syntax for the two-dimensional arrays. What is the type of the array? That is which type of data that you want to store and what is the name of the array. And I can write 2 subscripts. The same thing can be written as type. And here I can write 2 subscripts. And here I can write array name, which can be terminated by semicolon. Like this also I can write. The subscripts can be represented either here or after the name of the array. Right. Like this I can write. Now here this part is to be called as declaration. This part is to be called as allocation of memory. So whatever the array name here you are taking, the same array name is equal to new type. Whatever the type you are representing, the same type, size 1 and size 2. Here size 1 represents rows, size 2 represents columns. How many number of rows that you want to enter, how many number of columns that you want to enter, that can be represented. Here this is to be called as allocation of memory. This is to be called as declaration. Both declaration and allocation of memory can be combined in a single line. So here you can see type, array name, new type, size 1 and size 2. Now here you can see the example how a two-dimensional array can be represented. int number. Here, int is the data type, number is the name of the array. Since it is a two-dimensional array, we represented two subscripts, and the same name here we are taking. Array name is equal to new, whatever the data type here we are taking, the same data type we are taking, and here we are representing size 1 and size 2. That is, I want to enter 5 rows and 6 columns. That is, it can store a maximum of 5 rows and 6 columns data. That is, it can enter maximum of 5 rows and 6 columns data. Right? Do you understand? But if I want to add 2 rows and 3 columns, I can add. So totally it can store 30 elements. 5 rows and 6 columns means totally it can hold 30 elements. But out of these 30 elements, I want to enter only 2 rows and 3 columns. So here you can see, I can take these one. These 2 rows can be entered with these 3 columns. Right? That is totally, it holds only 6 elements. Right? Now, this is the maximum value. Maximum elements that can be stored in that particular array, that is represented here as the size. Less than that size, I can enter. Or up to that size, I can enter the elements. Right. Now, here, initialization of elements can be done directly by using at the time of declaration only I can enter. Now here I can write like this as well as like this also. Here type array name, list of values I can write, or type. Here I can write row 1 values, row 2 values, row 3 values, and so on separately. That is, for example, if I want to write int x is equal to, suppose if I have written the values like this, how these values can be entered? So if it is, since it is having 2 subscripts, it is having rows and columns. So how these values can be entered? 1, 2, 3, 4. That is, it takes 2 rows and 2 columns. Suppose, for example, if I have written only like this, so like this, if I have written, how these values can be entered, how these values occupies the, so it takes, now here we are writing 2 subscripts, so rows are there. Now these values can be entered like this. Here default value comes like this, these values can be entered, or otherwise these values can be entered as like this. Here default value occurs. Right. If it is the place, 3 rows and 2 columns. If it is the case, 2 rows and 3 columns. Right. So without having this confusion, I can use this type of representation. In this case, how I can write? I can write int x is equal to, I can write first row values, I can write second row values, I can write third row values, I can write fourth row values. Right. How these can be entered, how these can be represented as a matrix like this, these can be represented as a matrix. Right. So this is this is automatical declaration of the initialization of the arrays at the time of declaration. But if I want to do manually through the keyboard, I can use 2 for loops. One for loop is for the representation of rows, and other for loop is for the representation of columns. So we can use 2 for loops for entering the values into the 2-dimensional array. Now here you can see one example, what we have written for a 2-dimensional array, class sample. Here this is my main method. Here I declared an array which contains the elements 1, 2, 3, 4. Now I want to print these elements. Now here you can see for printing also, as well as for the initialization, in case of 2-dimensional array, for printing also I can use 2, I have to use 2 for loops. right? Since here only 2 rows and 2 columns are there, here row size maximum I represented and column size maximum I represented. Now here it prints. So initially I becomes 0, it is less than 2, condition correct. Here j is 0, it is less than 2, condition correct. Now first the value printed is ARR of 0, 0. So here this is the 0, 0 element. So here how these elements are stored, let us see. So here like this, these elements are stored 0, 1, 0, 1. These are rows and these are columns. So this element is 0, 0 element. This element is 0, 1 element. This element is 1, 0 element. This element is 1, 1 element. Right. Initially ARR of 0, 0. Which element prints? 1 prints. Right. After that, j increments, j becomes 1. Again, it is less than 2. Condition correct. So, which element prints? 0, 1 element. What is the 0, 1 element? 2 can be printed. And after that, again, j incremented to 2. Now, condition becomes false. Again, the cursor goes to I loop. I becomes 1. So, here condition less than 2. Condition correct. Again, j comes from 0. Here less than 2. Condition correct. So, here the element printed is 1, 0. Is nothing but third element. Now j becomes 1. Again, it is condition correct. Now here 1, 1 element will be printed, which is 4. Right? After that, j again becomes 2. Here the condition fails. Again, it goes for I loop. Here also condition fails. So finally, we will get an output of this one by executing this program. Right? So like this, the elements can be read from a 2-dimensional array. Now here you can see the execution of this one. So here you can see how this can be executed in a command line argument. Now I am going to show you how this can be executed in a command line argument. So here you can see this is my command line online compiler. Now here I have written the program, same program here we have written. Now I am going to run the program. Now here you can see the elements that printed are 1, 2, 3, 4. Now if I want to print these elements in the form of matrix, how I can change the program? So here you can see that this is a way of changing the program. So I can write simply a print statement here without writing anything, just simple print statement. And here you can see how my printing is there. Now here you can see in the form of an array, the elements can be printed 1, 2, 3, 4. Suppose if I want to give a space between them, now I can write like this. Now here you can see they are printed with some space, right? Now suppose if I want to increase the size, now how I can increase the size? Here you can see I'm going to increase the size, right? Now if I want to add one more row with the values like this, right? Now how these can be printed? Let us see, right? Now I'm going to run the program again. Now here only these 2 values are printed. Why? Because here even I given the third row and third column. Here I am not changed the rows number. How many rows, how many columns that I want to take. Now I changed those rows and columns. Let us see how these can be printed. Here you can see 1, 2, 5 first row values, 3, 4, 9 second row values, 5, 6, 25 third row values. Right? So all these are printed. Right? Now here you can see this is the way of printing the elements. How these elements can be printed. Right. Now I want to explain the enhanced for loop. How enhanced for loop can be used for printing for arrays. Right. Generally, how a for loop can be used? What is the general syntax for writing a for loop? How a for loop can be used? Now here you can see for I is equal to 0, I less than or equal to 10, I plus plus, like that I can take. That is, here we are writing initialization, here we are writing condition, here we are writing either incrementation or decrementation. Either incrementation or decrementation I can write. This is the general representation of for loop. But what about for each loop, which is also to be called as enhanced for loop, which is also to be called as enhanced for loop. Right. Now, how this enhanced for loop can be used? Right. So here you can see the enhanced for loop is also to be known as for each loop, which provides a concise way to iterate through the elements of array or collections. Right. It simplifies the process. Actually, for iterating over the elements of the array, we are using, if it is a single dimensional array, we are using one for loop. If it is a two dimensional array, we are using two for loops. Right. So, without writing much code, simply I can iterate over the elements of the array by using for each loop. Right. Now, what is the syntax that we follow for using this for each loop? For data type, variable, colon, whatever the collection or array that I want to iterate, that array can be written, and whatever the code I want to implement on each element of that array, that code should be written within this for loop. Right. Now here you can see an example for that. Now here I have written a class for each example. This is my main method. Here we declared a single dimensional array with the elements 1, 2, 3, 4, 5. Now I want to iterate over these elements and I want to print these elements, all these elements one by one. Right. Now here you can see for int num, here this is my integer value num, numbers. This is my array numbers. Now I want to take for every value of num, I want to take the value from numbers. So initially this value is assigned to num, that value is printed, then this value is assigned, then that value is also printed, then this value. So it iterates. The process iterates over all these elements. Right. Now here you can see the execution of this program also, right, in our code, right. Now, how the execution of this program will be happen, let us see. Now, I want to show you the execution in the same online compiler. Now, here this is my for each example, for each loop example. Now, here see, if I run the program, what happens? Now, all the elements are printed one by one. All the elements are printed one by one. Right. Now here, if I change the elements, what happens? So here you can see 20, 65, 98, 78, 50, 55, 89, 78, 100, 125, 165. Like that I have taken. The same values what I given here, same values can be given. Right. So now, if I want to find the sum of those values, how I can take the sum of those values? Right. Now, here you can see how I can take the sum of those values. Here I am taking sum is equal to 0. Right. Here I want to find sum is equal to sum plus whatever the num value that I am getting, that num value can be added. So finally, I want to print the sum. Right. Now here I am going to run. Now here it adds and prints all those sum values. Initially 20, 20 plus 65, 85, 85 plus 89, 174, 174 plus 78. So if I want to print only the final value, I can write this statement after this loop. Now here you can see now final value can be printed. Right. Now like this I can go for executing the for each loop in case of your programming. Right. Now here you can see one more example for each loop. So here array list is one type of another defined predefined list. Now here you can see we have taken class for each loop example. Here we declared an array list with the string items fruits. The name of the array list is fruits. Now I added apple, banana, orange to that list. So one by one. So for this list, I added these three values. Now I want to iterate over the fruits. For every fruit, the fruit value can be printed here. Now here you can see how these can also be executed. You can see how these same simple program for array list can also be executed. So here you can see. Now I want to run the program. So if I run the program, you will get those values: apple, banana, orange. Whatever the values we are giving, those values. If you want to add one more fruit to your list, you can add simply. So just by using this add method, you can add simply. Now I added mango. Now you can see. Now mango is also printed, right? So here over the fruits it is iterating. So first fruit takes apple, next fruit takes banana, next fruit takes orange, next fruit takes mango. So over the fruits it is iterating and every fruit value it is printing. Now all the fruit values are printing, right? So this is about for each loop. Now here you can see this is an example program which adds two matrix of multi-dimensional array, right? So here you can see the program. So here we are taking matrix addition program. This is my main method. Now this is a scanner class we are using. Now for entering the values, first I am asking enter the number of rows. Here that rows variable rows reads those values and enter the number of columns. Variable columns read those values, and here we are defining three matrices: matrix 1, matrix 2, and the resultant matrix, which is the result of addition. Now with the same sizes rows and columns. Now here enter the elements for matrix 1, right? So here I want to print input the matrix elements. So input matrix elements, scanner comma matrix 1. So enter elements of matrix 2. Now here we are inputting the matrix elements. Now I want to add the matrices. Now I want to print the resultant matrices. And finally I want to display the matrix. Now all these are the functions. So here you can see all these whatever the things we have written here. So this one, input matrix elements, next add matrices and display matrix. All these are the functions which were defined later, right? So here you can see those function representations. So here this is a function representation, right? So first one, the first one represents input matrix elements. Now here, in case of input matrix elements, it takes that scanner class as a parameter and input matrix as the parameter. And here it is going to read by using two for loops. Since it is a two-dimensional array, it is going to read the elements into matrix ij, right? And add matrices. So this is used to add the two matrices what I have, right? And display matrices. It is also using two for loops for displaying the elements. So these three functions were defined here, right? Now then we can have the resultant matrix can be printed there, right? So I hope that you understand, all of you understand all these concepts, arrays concepts. So here we discussed about what is an array, what is a one-dimensional array, and what is a two-dimensional array, how to declare, how to initialize, and what about the for each loop, and what is the lab program that we have. So all these things that we discussed here, right? Now I want to show you some example for in your online compiler. So for executing the array programs, right? Now here I want to show you the execution of your lab program. So how array elements can be readed and array elements can be added, right? I want to show that example. by the execution, right? Now here you can see how this can be executed, right? So here, this is your execution environment. Now I have taken class. Suppose here I am writing it as matrix addition. This is my program. So I want to write it as a matrix addition program. So first ARR1 array we are taking, so which contains the elements 1, 2, 3, 4. Now I want to take another one more array. Simply I can write the matrix addition without having the complexity. I can write the matrix addition, which takes the values 1, 1, 1, 1. And here I am taking the values. Here I am taking the values 2, 2. Right. This is another matrix I am taking. Now I want to add the elements of these two matrices and I want to print the some final matrix. Right. Now, so for that, first here we are going to initialize one more matrix, which is nothing but sum. It is nothing but sum. Right. So initially, whose value is equal to, now no need of initializing this. Now I am taking it as sum. Now here I am going to write sum of I comma sum of j is equal to, now what it becomes, ARR of ARR1 of I, ARR1 of j plus, now in the same way, the same corresponding element which is present in ARR2, that can be added, right? Now here you can see ARR2 of I comma j, right? Now I want to print these elements. I want to print all these elements. Now here you can see by running the program, you can see the output, how I can get. Now here it is having some error. So where I didn't put the semicolon, that's why it is showing error. Now here you can see. And one more thing, what is that one? Cannot find the symbol ARR. Now here I need to give not ARR, here I need to write sum. Right. Now it not been initialized. So initially it should be initialized with sum should be initialized with let us say it is initialized with 0. Let us say first initialized with 0, comma 0. Now the same values that I am taking. So here also right. Now here you can see those values are added and printed. Now here you can see how the corresponding elements are added. 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 4 plus 2, 6. So if you want to print them as a matrix, right? So how those can be printed, right? Now, what is the input matrices? If you want to print all the input matrices and if you want to print all the output matrices, all those things, if you want to print, how these can be printed, right? You can see like this. Now, first you want to print first matrix, which is nothing but your ARR1, your ARR1.